And welcome back. Well, in this next video in our build series, we're going to button up a couple things on our motor here and get it prepped to potentially get it dropped back into the vehicle today. At least get it physically mounted back into the vehicle today. May or may not get to doing all the electrical connections, but we will at least attempt to get it in there physically, or at least that's the goal. But one of the other items that we still have to take care of, and I commented that we may put the hub on after it was in the truck, but then it occurred to me it's much easier to be able to stop the crank from spinning while we tighten down the new bolt for the ATI balancer for that hub that we're going to need to have here. So what we need to do is get this hub, which is going to have the pulley on it for the accessories, and then the pulley for the supercharger mounted onto that crank. And if you remember, we're going to be using the keyway that was already provided to us in the hub, and we had the machine shop cut a keyway into the crank, and we installed that key as part of putting the front timing cover on. So I need to get a couple of tools here together and a plan together how we want to accomplish this. A couple of different ways we can do it. They make an actual, ATI makes an actual install tool for being able to push this onto the crank. But I'm going to try a method here that I saw another gentleman do online. You can rent these from the parts store. I happen to just go ahead and buy one from Amazon. I'll put a link in the description because it was cheap enough to do. OEM tools, that's the number there. And what this is, it is a long reach harmonic balance pulley installer. Now he was able to use this kit to be able to install his pulley. Now he did his on a Jeep. Granted, this is on a Chrysler, but we should be able to still do what we need to do. I'm just looking over the kit contents here and what it comes with. And I've used this before in this channel, but you've got this piece here, which goes against the pulley, and it's a threaded nut. It's about 1 1/4 inch nut, which I did go out and purchase a socket for. And I'll show you that here in a bit if this works. And this particular rod here, actually all of these rods kind of have the same thread pitch, like this one and this one. As far as these that fit, that screw into the crank, the thread pitch is the same, because remember, it's got to go through this bolt, and this bolt only accommodates one thread. And you can see up here at the top that they've got it listed for a number of Chrysler products, a GM product, and it looks like a Ford and a couple other ones here. Yeah, it looks like some kind of a bearing nut assembly is your E here. So let me get set up, because we're going to attempt to do what he did in his video and use a couple of these to help see if we can get this on here. Now, I've put crank pulleys on before, just using a standard crank bolt and like an older crank bolt just to push it on, and then finish it off by torquing a new bolt in its place. What you can do, you just need to make sure that you've got sufficient engagement of your threads into your crank, because you don't want to grab it by, maybe 2 or 3 or 4 threads, not have enough engagement on there, and the force of you pushing that pulley or this hub into place could potentially pull those threads out and make you have a bad day. That's where these long reach kits come in handy, because they allow you to get a pretty good grip far down into that crankshaft. You can get a lot of thread engagement. And what he ended up doing, which was quite interesting, I have to go back and grab, I think it was that one right there, if I remember correctly. He ended up grabbing one of those ones that didn't have the hex end on it and used it to be able to drive it on, but then use like 1 1/4 inch socket to come in through here. So he drove it on as far as he could until the rod finally came up to the end of the socket, and then he had to switch rods. So I need to go back and kind of review the exact, I'm going to go back and review the exact steps that he did, and then come back and kind of see if we can tackle this together. But what I'm also going to do is take a little bit of a assembly lube and smear up the inside of this just to help ease this on a little bit better. And then we'll put some on the crank as well. But in a sense, I guess, long story short, what we're going to do here is hopefully get that hub pressed in place and then get a final bolt in it. So let me go grab some more materials and I'll be right back. One moment. And welcome back. So just kind of reviewing what he did here, and this works. I will put a link in the, should appear in the upper right hand part of the video right about now. So I will link to his video and give credit where credit is due. But right now I'm just putting a little assembly lube on a crank to ease our install. Just using a little bit of an acid brush to thoroughly douse that down to help us with all of this. And put a little bit more on the inside of the hub, ATI hub. That's what I'm doing here, just kind of painting the inside of this hub. Again, I'm probably using way too much, but I'd rather have too much and not enough. Get all thoroughly snotted up there. Okay, so in a sense this kind of becomes a two-step process. One is having that kit, again, that you can rent from AutoZone, that OEM kit. And I did go out and purchase this monstrous 3/4 inch drive, 1.25 inch 6-point socket. And this socket fits this forcing bearing like so perfectly. It's in the kit. We also got a 1/2 inch to 3/4 inch adapter to drive that socket with. So what we end up doing is taking the first kind of forcing bolt here. Yeah, that was the first one that he used. We're going to take our hub. Remember, we were just going to line this up with the keyway that we had put in there for us, along with the key, and then the keyway and the hub itself. Just going to get those lined up, get that started on there. There we go, perfect. And now put a little bit of lubrication onto this forcing screw here. So now what we can do is take our forcing bearing, put it on our threaded rod here. Work this down, and we're going to start to thread this into the crank. And you can kind of see where maybe this is going to go. And again, it's a fine thread, so it takes a little while to get this thing threaded down. So once we get this threaded into the crank, and we're going to thread this into the crank until it just kind of bottoms out, and then we're going to back off just a little bit. That way we know we got plenty of thread engagement into the crank. but it should leave us with a little bit of a stub of a shaft that we can get our socket over. So kind of something like this, which is why we've got the bigger 3/4 inch socket, because it'll accommodate that little hex head on the end of that shaft. But basically we're going to end up with something like this. So we're going to thread this in as much as we can to get as much free space before the head of this bolt here reaches the end of that socket. And then once we bottom out on the socket to where this bolt comes out enough that it pushes the socket off, and you'll see it, we're going to switch out to a slightly shorter installation tool that uses the same thread pitch. There we go. So we got something like this now. So now if we thread this into our crank, okay, that feels like we bottomed out, and I'm going to back off about 1.5 turns or so. And now we should be able to put our socket on here. I'm going to push that bearing down just a little bit so it starts to engage that hub. I'm just turning it by hand, as you can see. Like I said, he did this on a Jeep, so I'm hoping we've got the metrics are enough the same here that we can kind of do the same thing. Okay, so it feels like we kind of got that that bearing you see there at the bottom, and then you can see we just got a little bit of a stub of that shaft sticking out there. So we should be able to take our 1.25 inch socket, there we go. Now we made contact. Let's see if I can back this out and turn that in any more. One moment, my hands are all slimy. So you get the idea. Let me go ahead and work on getting this set up a little bit more, and then I'll bring you back and let me get my hands unslimed here. One moment. And welcome back. So just to recap, we've got our forcing bolt, or forcing bolt, however you want to call it. We got it threaded into the crank just until it bottomed out, and then backed it off about 3/4 to a turn. And then we've tightened up our pressing tool where it's made in contact with the bottom of that hub. So that's given us a little bit of space between now the top of this bolt, and at least until we bottom out in the bottom of this big old socket, that we should be able to start driving this on. And again, it's just a 3/4 socket that I'm just going to use a 1/2 inch to 3/4 adapter to start this process. And then when we bottom out, we'll switch. Okay, feels like it's going. Yeah, we're making progress. We're getting it on there. Okay, so yep, we've hit the point now where it's slipping off because the bolt has come up enough that we can't drive it on any further with the socket that we have. Yeah, that's why it was slipping. So now we can back that off. Okay, yep. Okay, there we go. We've got our piece out, but we still got some work to do. Now we can take this one out and now get our shorter bolt, which is one here at the bottom that you can see. And yep, we're still all lined up in there. Everything looks good. Seems to be driving on okay. Now I'm going to go grab the shorter one per his instructions, which has the same thread pitch. And then I'm just going to lube this 14 screw up a little bit. Always a good practice. And we should be able to wash, rinse, and repeat. Except we'll have a much shorter shaft and should be able to get some more bite using our 1/4 inch socket to help drive this on. Okay, so I'm going to just continue to twist this. I'll get this set up and I'll bring you back just so I'm not burning a bunch of camera time and you're waiting on me to thread this. One moment. Oh, I'm sorry, I just realized you're a little high. Let me fix that. So once again, we're just putting our 14 screw in until it bottoms out on the crank. And I'm going to back it out about a turn and a half. And I'm just going to take the center bearing that pushes that on. And I'm just manually threading it down that piece of shaft until it hits the bottom, which we have, of that hub again. And you can see we've got a lot less material sticking out here. So we're going to see if this will allow us to finish sending this home. It allows us to get another bite on it. And generally what happens is you'll know you're seated when this starts to turn the motor over. And then when we take the bolt and the little bearing piece out, there should be a little, just a little bit gap. In other words, the surface of this won't be quite flush with the crank. There'll be a little bit of a gap on it, and I'll try to get you in there and show you what I mean. There it goes. Okay, it just started turning the motor over at that point. Yeah, a little bit of effort, not gonna lie. And you can see we're starting to engage our hub into our seal. We might be good at this point. I think we might have a little bit more to go. But we are starting to turn the motor over. So I'm just going to check it. I'm going to back this out and check it. And of course it's hitting resistance. So what I'm going to have to do is stop the back of that crankshaft from spinning so I can get the torque off of that. So let me put a couple of bolts back there and I'll contact you back. One moment. And welcome back. So we're not quite there. We're close. We probably got about another 3/4. It's just getting tight enough on that hub there that it's causing the engine to spin over. And I can tell you by looking at the hub and where this outer pulley piece is going to align, just to show that to you. Now this is a bit of a friction fit. They are machine surfaces, so they're only going to go on one way. And just kind of looking at that, yeah, because our water pump pulley, yeah, you can gauge that with our water pump pulley, and I can tell you we're not quite on far enough yet. And I think it's just the pressure at this point that's causing this, because this hub is a bit of a tight fit, not gonna lie. Okay, so what we need to do is I'm going to just put some bolts in the back of the crank just to keep the motor from spinning. I'm going to come back here and hit this and see if we can get this to seat a little bit further. Like I said, it's going on. It's just it's a bit tight, hence the lube. So let me go take a look at this and I'll bring you right back. One moment. And welcome back. So I just got a couple of bolts in the back of old flex plate bolts in the back of the crank and just got it kind of wedged with a pry bar up against the engine stand to keep this from turning. Like I said, it's almost there. It's just an extremely tight fit here, it looks like, towards the end. Probably a little bit tighter than I would like. But we're going to see if we can get this to go on the remainder of the way. And go from there. There we go. There you go. That's getting pretty snug. I think that's tight enough. I'm just going to get an impact on this. Sorry for the noise. Back that bolt out and we'll take a look. Loud noises. Headphone users beware. There we go. So we're out. Let's check our gap. Well, we still got a pretty good gap in there. Yeah, we still got a little bit of a gap. A little bit more of a gap than I would like. Yeah. So we may have to give this another go. Actually, before I do that, before I say that, let me... let's check our pulley. There we go, our pulley is on. And what's going to happen is we're going to use the inside 6 ribs of this pulley. Let's compare it to our water pump. No, yeah, we're still about another half or so out. It's still not quite where it needs to be. And what I'm looking at is the gap that's between the face of the crank and the outer of the pulley. It should kind of look like the OEM one, where there's just a little bit of a lip, maybe like a 1/8 inch or so lip. Generally, once they start to spin the engine over, they're on tight enough, but this ATI hub is proving not to kind of be that way. So I'm going to try to hit this a little bit more, and I'll bring it back. But if it gets too difficult from where it is now, then more than likely what I'll do is just put a puller on here. We're going to back this hub off to make sure that we don't damage anything. And again, just trying to err on the side of caution here. So give me a couple minutes to work on this and I'll bring you back. 1 moment. And welcome back. Well, we got our hub on at this point. And what I'm going to do is get to a side shot here in a little bit and kind of show you what it looks like. But to recap what we did is that following that gentleman's video, which the link will come up on the right hand corner here and cover this, we started with a couple things. The OEM kit, the OEM long reach harmonic balancer kit, as well as this big old hunkin' 1 1/4 inch socket. And what we were doing was just using this to kind of get everything together. Started out with this longer bolt, as you saw, got it threaded into the crank till it bottomed out, backed out a little bit, and then used this piece here, the forcing bearing, with that socket until the head of that bolt stuck out enough that we could no longer get the socket around that nut. So then we switched out to the smaller threaded rod in here, which is number A in this particular kit, which the difference is it doesn't, it's a shorter rod, but same thread pitch. So we were able to kind of start with this one and get it in there and get it to basically do the same thing, get it to bottom out the crank, back out just a little bit, and then use the rest of the length to, again, with the socket, turn this down to get it locked into place. Well, we ran out of throw on this one, if you remember. So we ended up just putting a couple of nuts, old flywheel nuts, in the back of the crank and blocking it off with a breaker bar in the back of the engine stand. And we were able to kind of get it to go in a little bit more using a manual, just 1/2 inch ratchet. And it finally got to the point that I thought it was seated. So it kind of looked good. The belt looked good when we held it up there for alignment. But just to let you know, what had happened was it actually wasn't on there quite all the way, as we found out. So if you look down inside that bore, get you a little closer, get you some light, you'll see the gap between the crank and the head of that hub. And that is that's pretty much almost what the gap looks like when you're using a factory harmonic balancer. So the first time we did it, when we couldn't get it to kind of go in anymore, just using a 1/2 inch wrench, or 1/2 inch ratchet, I should say, we thought we were good. We were bonded out. We had it. So we did a couple of checks, and it kind of looked good from what we were seeing. And then when we went to put a crank bolt in it and started to bring it up on torque, it actually finished pushing in the rest of the way. So just be mindful of that. So what had happened was we ran out of throw, so to speak, using the socket, switched over to a 1/2 inch ratchet, but we just didn't have enough leverage using the 1/2 inch ratchet to finish driving this thing on. Now, I will comment that this is the tight fit. It's tighter than a standard crank pulley or standard crank balancer, harmonic balancer, however you want to call it. Now, the ATI book does state that, you know, it needs to be kind of a tight fit for it to do what it needs to do. But unlike what I've seen in some videos online, this one, it did press in. I'm not going to say that it didn't, but it did press in a bit more difficultly, with a bit more difficulty than a factory one would. So I wanted to bring that to your attention that we thought we were there until we went to try to torque up a factory bolt, and it went in the rest of the way. Now, what you're seeing kind of up there in the corner, and I've covered it up, was the little slot that the keyway is in. Remember, the crank is keyed into the hub with a keyway the machine shop cut rather than us using a pinning kit. So just to keep any oil that may leach through that keyway, because the keyway and the crank does get cut all the way to the end of where this balancer should stop, and to keep anything from, you know, finding that keyway and potentially leaching through, I just put a little bit of RTV right at the end of that keyway right before we put a bolt in there and torque it down, just to help eliminate any drips or, you know, seepages that may come through that. And ATI does state in some of their installs for their hubs, when you read the instructions that come with it for other makes and models, they actually say to do that if you're not going to use that keyway, is to put a little bit of RTV in it to keep it from leaking. But even though we do have a keyway in there, we're just doing it for the added protection. So what I'm going to do next is just kind of place this ATI pulley on their hub, and this is quite the machined fit. It will only go on one way. You kind of have to just wiggle it, get it to all line up, get it to press in place. Now, we're not going to leave it there. We'll do the final assembly when it's inside the truck, but what I want to do is, sorry for the noise, get you off to the side here. And then what's going to happen, get you panned up. We're just using the water pump pulley as a reference. Now, this is an 8-rib pulley on the bottom. We're not going to be using 8 ribs because obviously the rest of the accessories are only 6. So what's going to happen is you're going to use the first 6 ribs from the inside out in this particular application. But if we take a belt, and we get it on our first 6 ribs here. Now you'll notice there's a little bit, you might see a little bit of a gap between the edge of the pulley and here. That's where the belt starts to fall in. You can't go all the way to the edge because now it's not inside the grooves. That's where it kind of falls into the grooves. And then if we loop it around the water pump pulley and just kind of give it a quick eyeball, that looks pretty straight. Yeah, that looks pretty straight on from where it sits. So I think we'll be good there. What we'll do next is that we're going to finish getting our crank bolt in here and get it torqued, since it'll be easier to, again, block that crankshaft off on the engine stand. So we'll get our bolt torqued up to 127 foot-pounds, it looks like, per the book. I did have an ARP crank bolt I was going to use on this, but for another project that I didn't use, so I was going to use it here. I can't find where it went, unfortunately. So I'm just going to use a brand new factory bolt instead, which will be fine. So I'm going to get this torqued, and then when I bring you back, we're going to get it off the engine stand and see if we can get the rear flywheel in. I'm sorry, rear flex plate, and prep to hopefully get this engine back inside this vehicle. So I'll bring you right back. One moment. And welcome back. So what you're looking at, if you remember from our parts video, is our CircleD high stall torque converter. And I think, if I remember correctly, I think this is the 34 to 3600 RPM high stall triple disc 258 millimeter torque converter. If you, in my case, when I was searching for vehicle specific ones, this one didn't come up right away. So I ended up ordering this one from a performance shop, and I'll put a link to his website below. And according to my tuner and to my performance guy here, who happens to do the torque converter / cam testing for my tuner, this is the one that is spec'd out to match the cam that we're inputting, which is why we're going with it. So again, I believe this was 34 to 3600 RPM high stall triple disc converter, 258 millimeters. So if you go to the website and search CircleD's website and search for 258 millimeter, I think it comes up with one or two choices, and the one choice in there is for Dodge, and I forget who the other choice is. But we went ahead and printed out some installation tips for this converter. So before we put this, obviously this engine back in this vehicle, we've got to have the converter in there first. And again, this converter is spec'd, and the reason why we're getting a high stall is that it's made to marry with the power range of the cam that we're putting in. Now, I'm not a torque converter individual nor a cam individual, so I don't want to try to go too much in depth on that. But basically, you know, the power band available by the cam is going to be matched with the behavior of the torque converter to, I guess, to, if I said that correctly, it's putting it in really basic terms. So one of the things they want us to do on our install tips guide is to put about a half a quart of fluid in the converter for pre-lube. So we're just going to let this thing sit here for a little bit. We've got a quart of the same ATF4, same manufacturer, out of the same case that we did when we did the filters in this a few months ago as part of getting it back up on the road. It's one reason why I didn't want to put the new transmission pan on or the new fluid in yet. I want to use the same type of fluid that's already there. Plus we want to, you know, get a feel for how things are going to work before we, you know, do another transmission service, seeing that we just did one a few months prior to taking the engine out. And I understand, according to their instructions, this may take a few minutes for this to do. So we're just going to pour it down the hatch. And we'll let that wait. We'll let that drain. And we'll keep that up until we get about a half a quart in it. And then I'll bring you back and we'll attempt to get this into the transmission and get this seated correctly. There's a number of gears down in there, and I'll bring you back and zoom you in a little bit so you kind of see this a bit more. Hold on. There we go. So I've got you some additional light, and hopefully you can kind of see those teeth down in there. So that's what we're looking to engage. It looks like we've got 2 splines at least that have teeth which match up to our transmission. So one of the critical issues of torque converter installs is making sure that we get everything engaged that needs to be engaged, so that so that we're engaging our pump, getting our pump to spin correctly. Because without our transmission pump, we will burn up our transmission in very short order. Yeah. It's only about a quarter of a quart so far. So as you can see, this is going to take a little while to bleed down. And, you know, you can take it and kind of, I've seen individuals kind of squish it from side to side to help that load in. So I'm going to continue to work on this, and I'll bring you back. One moment. And welcome back. So I got you zoomed in a little bit on the transmission. I'm going to try and film this, and hopefully we can keep everything out of the way that needs to be out of the way in order to do this. These torque converters are not light. We've waited for a little bit. We've got about our half a quart of fluid that seems to kind of drain down and settled inside the converter at this point. And what we're going to do is, again, we're going to pick it up and get it stabbed in here, trying to be mindful of our seal so that we don't muck any of that up. So we're just kind of have to potentially rotate this a little bit and rotate it and rotate it. Just basically just kind of keep rotating it while at the same time trying to push it a little bit onto that shaft to kind of hopefully get everything to bite. Let's see here. I'm trying to find a spot that's comfortable to do this. Now the convenient thing is I'm standing where, you know, the engine used to be, so it's pretty nice that we have a straight shot at doing this and not trying to do this, you know, from ground level and picking stuff up. Let's see if I can get this converter. Now, let me get my light out of the way because I'm going to run my head into it. Let me just pull this out of the way for a second. Yeah, there we go. Okay, that's still giving us plenty of light to see with. Okay. Okay. There it went. Hopefully you heard it. I don't know how much my face blocked that shot. Hopefully not a lot. But as we kind of felt it engage once, engage twice, and then as you saw, as we turned it, you heard it just kind of click in place. So that was pretty nice. We didn't even lose that much fluid, which was nice. Okay, yeah, that's spinning nice and easy. I don't know if you can kind of hear that. You hear a little bit of a click, where my understanding is that's where it's engaging the pump. Okay, nice. Okay, so we got it in, good deal. Put that down at the bottom, and we got our 4 bolt points to bolt our flex plate back up to our converter. So awesome. So and now what we're going to do, so like I said earlier, we're going to try to get the engine off the engine stand, get the flex plate installed, and see about getting at least the engine back in here and mated it back up in a mechanical sense at least. With that being said, I'll bring you back. 1 minute. And welcome back. So we've got ourselves on our engine hoist at this point, just prepping to get our motor in. And as you saw in the last clip, torque converter's in, nice shiny new billet torque converter's in. And now what we've got next is, while it's hanging precariously by its hoisting chains, we've got to get this flex plate reinstalled. It's not terrible. Just like we did the last time we did one of these, we upgraded to some ARP 12-point bolts to take care of that job for us. And they are 16 millimeter, in case you're curious. So just like any other ARP bolt, we're going to put some Loctite on the threads, and then we're going to put a little fastener lubrication right underneath the head of that bolt, so when it spins we get a bit more accurate torque reading per ARP. And the torque spec for these bolts, I think, are 55 or 60 foot-pounds. I'll look it up and I'll clarify it to you when I bring you back. And of course, we've got our backing plate here, which is going to go on behind our flex plate. And last time we had this out, if you remember, we wrote the word out on it to remind us which direction this faces. So it's going to go on the crankshaft like this. And that bolt pattern is a unique bolt pattern, as they are with most flex plates. It's only going to line the bolt holes are only going to line up one way. So once they get them lined up, a little bit of Loctite, a little bit of a fastener lube, we'll get them in, we'll get them torqued, and then we'll bring you back. And I'll try to film some of the engine install, but to be honest with you, we've got to be in a lot of places at a lot of times, keeping an eyeball on each other, making sure that this is going according to plan. So it might be a little bit difficult to film that and then keep things safe at the same time. But you know the drill. We got nice easy access with the front of the truck being gone, radiator and all that. That should afford us the luxury of being able to walk in here and kind of jiggle the engine left, right, up and down. We're probably going to fight with the transmission a little bit because this is a 2-wheel drive and it's not supported in the front like it is with a 4-wheel drive model. So we may have to do a little bit of a dance with the floor jack so we can get our standing jack and our blocks of woods out of the way. But basically the goal is going to be get the transmission bolted up to the block first, and then we'll take our motor mounts, which we'll have dangling there, and then pick them up, swinging them in a position, and then start those bolts. And then once we have everything started, we'll get the rest of the transmission bell housing bolts in place, get that at least hand tight, and then we'll come back and finish up with our motor mounts. And no, I haven't forgot about the kill people bolt yet. We got to put that back into our steering column. And the reason why that's called a kill people bolt is that if you forget to put that bolt in and that linkage comes disconnected, you can no longer steal your vehicle, and as a result, you're potentially going to kill somebody. So with that being said, we're going to work on this, get this flex plate in here. Like I said, I'll try to get some shots of this as we're getting this into place, but we'll see what we can do. Catch you in a bit. And welcome back. So just want to show you in the process of getting this torqued. We've got it installed. We got our backing plate on the infamous one that will constantly fall off as we're trying to get the engine installed. According to the ARP documentation for that bolt kit, they are looking for 70 foot-pounds. And the torquing sequence on that, if I can have the paper with the, thank you. And there's your torquing sequence. So we're going to follow that sequence, bring them torqued, and bring it back. One moment. And welcome back. So you can see that we've got our Sharpie marks on here just to verify we've got all 8 of our bolts now torqued to 70 foot-pounds, 2 passes. And right down here where you got this little access kind of dimple or cubby hole in your oiling pan, where they made room for you to get in there and be able to put your flex plate, the torque converter bolts in, you'll notice we've got this really odd shaped hole down here first. Instead of it being round, it's kind of, it's round, but it's got these 2 flats in here, so it's not completely round. And what that is, it's kind of an alignment, at least on Chryslers that I'm aware of. You start with this one when you bolt your flex plate to your torque converter, and that kind of lines the torque converter up for everything else. If you don't start with that one, then what could eventually happen is that you'll get 3 of your bolts in, go around, try to get the 4th one in, and it won't line up enough to get the threads to engage. So that's the one we want to start with first. We rotated the engine around a little bit just so we were kind of in our starting position. And then now we're going to work on seeing if we can get this motor back into this vehicle. So we got a little bit of coordination to do with who's going to be doing what and who's going to be doing where. Like I said, I'll try to catch some glimpses of it, but I'll bring you back in a bit. And welcome back. So just real quick, I promise I'll show you some of this. You can see that we're in the process of supporting our transmission. So because the transmission's front heavy and there's no brace on it, without some support, it wants to come forward, and that torque converter can potentially fall out of position, which wouldn't be good. So we got a floor jack underneath, a hydraulic jack underneath that with a piece of lumber, just kind of picking it up as we raise the lift and the truck up, so that way we're keeping the transmission nice and level, nice where it needs to be. And you can see we're slowly getting our engine into position here, getting ready to start to lower it, just making sure that we're mindful of items like this, like the rear wiring harness. We need to watch and make sure that we don't snag onto that with a piece of it. So it's just kind of lower watch, lower watch, lower watch. And, we got individuals crawling under the lift to kind of look at things, and individuals staying up high to kind of operate the cherry picker. So it's, like I said, it's just a lot of moving parts. But as you can see, not having I said it before, and I probably said it 100 times, and I'll say it again, but not having the radiator in the front of the truck here, you can see we don't have to come up near as high to start dropping this motor in place. So there you go. There's a little bit of preview. We're going to continue to just try to lower this. And like I mentioned earlier in the previous part, we went ahead and installed the oil dipstick prior to putting the engine in here, because it's easier to do that without. You can do it with it in the vehicle. It's just more difficult to do. But we're going to continue on to work on this, and I'll bring you back. One moment. And welcome back. So we've got our 2 lower transmission bell housing bolts started. We haven't got our motor mounts in yet. They're just kind of waiting in the breeze. And what essentially we're doing is just getting the motor lined up and at least in position with the transmission. Obviously, before we tighten anything up, we're going to get all of our bolts started, but you can see our bottom bolt there on both sides. And then basically by pulling these two together, it's going to help put everything into alignment where we need it. And then once we can get the engine in a little bit closer, then we should be able to start putting our bolts into our motor mounts that you see there. Again, it's just a game of constant manipulation because you can see that we had 2 jack stands underneath here supporting the transmission at various times, keeping it at level. We got a floor jack there with another block of lumber on it, holding our exhaust up out of the way for us. And we got 2 individuals out manipulating the cherry picker and kind of pushing the engine left and right to help get our bolt holes line up. And yeah, it's fun. Like I said, it's just a lot of moving pieces and a little bit of coordination. And I'm sure you 20-year veteran plus guys that pull motors all day long are probably laughing at this, because I'm sure you can do this job in about 15 to 20 minutes. But you know, it's interesting. So we're going to continue to get the bell housing bolts in and at least get everything started by hand. And then we'll bring you back. One moment. And welcome back. So we've got, they're not torqued, but they're just kind of hand tight. But we've got all the transmission bell housing bolts in on this side. And hopefully you can see, you might be able to see that there, but our motor mount bolt holes are starting to line up to where we need them to be now that we've got the engine kind of pulled towards the transmission, kind of where we need it. And again, we didn't necessarily pull with the bolts, so I just want to stress that we got it mated. You know, everything was hand threaded in, and everything just hand threaded tight. And that, like I said, that got everything into alignment, because I don't want everybody, I don't want people to think, you know, that we're pulling a, you know, 400, 500, 600 pound motor by a bunch of transmission bell housing bolts. We still have the cherry picker attached on top, which still has the bulk of our weight. We're just taking advantage of kind of the weightlessness there and using the transmission to help line up the engine block, which then allows us to get our new engine mounts lined up and bolted in. So we're going to continue to work on getting bolts in here. I am putting a little bit of blue Loctite on the engine mount bolts just because they had some Loctite on them when they came out. And I'll bring you back for the next one. But yes, as you can see, you might want to, let me get you some light so you can see what kind of, that was some of the aftermath. You can see where we were using the scissor jack of the 4-post lift as kind of a counterweight with a ratchet strap around the tail end of the transmission there, just to help keep the transmission held down as we were raising the vehicle up. And then also being mindful of, because what would happen, again, just to reiterate what happens here, since there's no brace because it's not 4-wheel drive, the front of this transmission would dip down. So one of the ways we do is to counter that, along with some floor jacks, is you can see the ratchet strap there, just using that scissor jack as a counterweight. Again, just different things, kind of help hold things where they need to be. Probably not 100% OSHA approved, but it's getting the job done. So we're going to continue to start bolts, and I'll bring you back. One moment. And welcome back. So you can see we're just in the process. We've got all our bolts in hand tight at this point. All the transmission bell housing bolts in, to include the ones at the top, making sure that we've got them into like the various brackets. Some of the upper transmission bell housing bolts also served as hold downs for fuel lines, evap lines, things of that nature. We got that taken care of. We've got all of our engine mount bolts in hand started at this point. We're going to wait till we release the pressure from the, or I should say the assist from the cherry picker. Once the engine mounts have the full weight of the engine on it, then we'll come down here and tighten them. We also went ahead right here, since it was in our bolts bag for our engine mounts, and went ahead and put our new knock sensors in. They're not tight, but they are there for when we run the electrical harness in here. We'll connect them up and we'll tighten them down at that point. And what we're using is a set of NTK knock sensors for this vehicle. So we've got NTK oxygen, NTK knock, and NTK spark plugs. What can I say? They are an OEM from Mopar, so they'll work for me. And we went ahead and reached in, and we can rotate and turn our torque converter. So I've got the first bolt hole in the torque converter lined up with the little special hole we told you about in the flex plate. So that is ready for us to start putting bolts into it when we get to that point. I think what we're going to do next is we're going to release the cherry picker, let it put the weight, like I said, the full weight of this engine onto those motor mounts, and then we'll get the motor mounts tight, and then we'll get the bell housing bolts tightened at that point. And then we'll kind of evaluate from there. So I'll bring you right back. One moment. And welcome back. Well, with 6% of battery, let's see if we can make this quick. As you can see, we got the motor in at this point. We got all the transmission bell housing bolts tight. Engine mounts are tight, and engine mount bolts into the frame are also tight. So we have the motor back in its home. As you can see, it is physically connected, but not mechanically connected just yet. So when we go underneath in a follow-up video, or I should say in the next video, we'll finish getting the exhaust hooked up to the collectors, get the O2 sensors in, and at that point in time, we'll put the bolts in for the flex plate to torque converter connection. And that will then mechanically connect us at that point. So with that being said, for each of you that have subscribed so far in 2023, I thank you immensely. I believe we may be right at the 2,000 sub mark, just right before 2024. If not, we were still very, very, very close. So I thank each and every one of you for that. If you have not subscribed already, please consider doing so. It'd be much appreciative. And wherever you are, if it's already been New Year's for you, then Happy New Year. Belated Happy New Year. If not, I wish you a Happy New Year upcoming, and look forward to 2024. So this will definitely be our last video for 2023, and I'll see you in the next one. Thank you much.